All right, perfect. So we are going to move from electrical to computer science. So if you've never done any coding of any kind, I'm probably going to be moving a tiny little bit fast. Um, if you've already coded and you're kind of familiar with coding in general, I'm going to be moving a tiny bit slow. And you're going to be like, all right, I got it, I got it. Okay, so I'm going to try to find a happy medium. And this is the same medium speed that you'll need to find in your classroom. So, quick show of hands, or in the chat, or thumbs up, or whatever. Have you ever done any coding of any kind before? So, give me a thumbs up if you've done anything of any kind, maybe a little bit. Okay, I got a thumbs up a little bit. Thumbs up, thumbs up.
Including Scratch or not?
Yeah, scratch. Yeah. Okay. Yes for Sandra. And then I think, uh, what about my Brandons? If y'all can pop it in the chat. Okay, so seems like most people have done I see a thumbs up from Lloyd, a sort of thumbs up from Catherine, a thumbs down slash little bit from Jen, tiny little bit. Okay, so we got a lot of beginners and then some with a little bit more experience. Perfect. That is helpful context. Again, I would encourage you to ask that same question to your students. So you kind of you kind of know where to start and how to balance your classroom. And then, coding logic is the same regardless of coding language, right? Syntax and how you talk to the computer is completely different, whether it's Scratch, whether it's Arduino, whether it's Microbit, whether it's Excel. Like, how you do the sum function in Excel is different than how you like use a calculator to push the buttons and press equal. So, you're accomplishing the same goal, but it's going to look a little bit different. So, logic, pretty much universal across all computer science programming languages. Syntax, like how you communicate specifically, is going to be different. So if you've never done Arduino coding, the syntax is going to look a little bit different, but hopefully the logic and the thought process is the same. So let me share my screen. Hmm. So I'm sure I'm going to have the same error on Louisiana Training Platform where I only have the 4x4 notes potentially. But you'll see computer science uh, recommended project. So you've got part one and the extension project. So two different video recordings of the slides. So we'll kind of do what we did for the first part, which was to go quickly through the slides, like using the slides as a guide, and then do the projects. There is a solution file for the primary project and the extension project. And that's going to be the coding piece of it. And then this is the student handout. So the overall goal is to program the student's name using Morse code. So we've got a little bit of, I guess that's an ELA standard, learning about Morse code. So if you've never done Morse code, there's in the student handout, it gives them um, the letters for the dot, dot, dot dashes. And then it gives them the uh, instructions. Okay, so they're going to light up an LED to be on for 5 seconds and off for 5 seconds. So that's what we are going to do together as part of the training. And then that's also what you will do together in a demonstration format with your students. And then challenge two is the one they kind of work on independently, which is where they are going to use two LEDs to write their name using Morse code. And they've got instructions on what each dot and each dash should be, etc. And then someone's going to test it by watching the dots and dashes and seeing if it actually spells their name. If kids have really long names or apostrophes or things like that, they can do, their first, middle, and last initial, just as long as they've got like 3 to 4 letters, like they get the gist of it. Okay. So you can make those accommodations as you see fit. Okay. So In the teacher note piece of it, yeah, I only did the 4x4 ones on these for some reason, so I'll need to put the year-long versions. You do have to do electrical before computer science. Is the only one that is truly recommended or truly required to be one before the other, just because you can't get a circuit to blink if you don't know how to build the circuit. So here are the slide decks for part one. Again, the videos are posted, available. The biggest difference from your circuit is if you notice here, well, I guess I gave you a preview. But what you would do is kind of show the kids, okay, this is the code and this is the circuit. So the first thing we do is look at the circuit and what is different about this circuit versus the circuit that we just built. And the kids should notice that there's no 5 volts, right? Before we had 5 volts and we brought 5 volts over to our board, but right now we have it plugged into pin 6. Okay, and this is the long leg of our resistor or LED. And so what this means is instead of saying, I'm sending you power all the time, right? That's what 5 volts is. That's like turning on your light switch, right? Or plugging something into the wall. Instead of saying, I'm giving you power all the time, you're saying, I want to control when you have power whenever I tell pin 6 to do something. So I'm going to tell pin 6, now I want you to have power. Now I don't want you to have power. Now I want you to have power. Now I don't want you to have power. But when you're connected directly to 5 volts, you can't do that, right? 5 volts is like on, off, like there's no controlling it. So the way that you use coding to talk to your Arduino is through using the pins, okay? You have 13 pins available here. These are digital pins. A digital pin, all you can do is say pin 6, you're on, pin 6, you're off, pin 6, you're on, pin 6, you're off. You can't tell it pin 6, you're going to get a little bit of voltage, right? It's either on or it's off because these are digital pins. Your analog pins is where you can say, okay, pin 6, I want you to be on 20%, or I want you to be on 30%, or I want you to be on 60%. So you can control it. Or you can connect a sensor to it that has a control. So if you think of like a dimmer switch on your light switch, like it maybe like in your dining room or something, you've got some lights that are on a dimmer. So you're sending it power, but you're using a switch to control how much of that power actually gets to the end product. So for the purposes of this class, the intro class, we're only going to be using the digital pins as on off. Okay. This is the code. So if you've never done any coding before, there's different parts to the code. But basically, well, I'll step through them. Okay. This is just basics of computation. You get an input, the code is going to transform it. You're going to get an output. This is a short little video about how computational thinking is kind of like a cake. Talks a little bit more about the different steps for computation, an input signal versus an output signal. So an input is going to be if you're reading a value. So like maybe you're trying to identify what the temperature is in the room, or you're trying to identify if you hear a sound, or you're trying to measure humidity. Those are inputs. Outputs is when something on the board is doing something. So like your LED would be an output because you're going to tell the LED what to do. You're not asking the LED, what is the temperature, right? Digital signal. So you can have a digital input or a digital output. This is what they look like. Digital is on off. So you're either 5 volts or 0. There's no in between. Those are your digital pins. The opposite to digital is analog. Analog is, so we have the same examples here, right? So a digital clock, a digital multimeter, and a digital buttons on a joystick. So it's either up, down, left, right, versus analog So you've got a continuously running clock, a continuous setting on your multimeter, and then these are your analog joystick controls. Because again, there's no on off you can control. I'm going to move it a little bit, or I'm going to move it really fast. Okay, so comparison, this is more of a wave format where you can be anywhere along the curve. This is where your analog pins are. You can, so there's really three components, right? There's input versus output, there's digital versus analog, and then there's reading and there's writing. And maybe it'd be helpful to have an intro slide on that now that I'm saying that out loud. But digital, analog, input, output, reading, and writing. So what is the difference in reading and writing? So reading is when you're asking a signal what its value is. Writing to the code or writing to the board is where you're telling it what value to be. I mean, it makes sense, right? Reading, you're reading the value, writing, you're actually writing a value and telling it to be that particular value. So the syntax is to say digital write, parentheses, what is the pin number that we're talking to? So in our original picture up here, right, we're talking to pin 6. Okay, and then we are going to tell pin 6 to be either high or low. Right, it's a digital pin, so I'm doing a digital write. I'm going to tell pin 6 to be high or low. Okay. High means the LED turns on if it's plugged into pin 6. Low means the LED will turn off. And as long as it's plugged into pin 6. Okay. When we are writing to an Arduino, when we're comparing it to that initial transformation or input transformation output, the input is to tell the pin what to do. So write pin, I guess I should probably make this 6 to make it consistent, right? Write pin 6 to go high. The transformation occurs in the board, and then we see the output, which is that the output bit pin does what it is told to do. So the output pin will go high, so 5 volts will get to pin 6, and it will be on. Reading, we can also read, so we can ask the LED, are you on or are you off? Like, so I'm going to check pin 6 and say, does pin 6 have 5 volts or does pin 6 have 0 volts? What do you actually have? Okay. So this would have to be set up as an input. Typically we're not asking the LED if they're on or off. We're actually asking a push button. That's the more common scenario. So if you think of like, anything with a remote control, the code inside is either saying like, is the button pressed or is the button not pressed? And you can have hard-coded buttons. So where like you press the button and when you push the button, it physically closes the circuit. So it's putting metal to metal and closing that circuit, in which case there's no coding that happens, right? So I can add a push button to my circuit that is physically going to close when I push the button, or I can program it using computer science and coding to say, okay, when that push button is closed, that's going to close the circuit, but I also need to send power to that pin and to do other things, right? So maybe when I push the button, turn the LED on. When I push the button again, turn the LED off, right? You can't do that without coding if it's just a physical switch. So I'm trying to think of an example. So using a push button, using only physical computing power, so no computer science, would be like if you had to push the button on your TV remote control the whole time that you were watching TV, right? Like the only way that the TV was going to stay on is if you were physically holding that button down and saying like, I'm making the physical connection to send power to the TV. And that is, I got to hold it down the whole time. If you do computer science, you can press the button and let go. It sends a code to turn the TV on. You press it again and it sends a code to turn the TV off. So, when you wire your push button directly to power, you're limited to doing things only like when you're physically closing the circuit, because otherwise the circuit is open and no current is flowing through it. So, anyway, when you are writing, you need to tell it where you're writing to and what you are writing. When you're reading, you just need to tell it where it's reading from, right? I'm not giving it a value, I'm asking it for a value. So it's just gonna be digital read, and then you say read pin 6. Like, tell me, pin 6, are you on or are you off? Are you high? Are you low? And so there's only one input there. Okay. So again, if your push button, for example, is plugged into push 8, you're going to read the push button status. And then based on that, you're going to do maybe when you push the button or when the button is high, you want the LED to be turned on. These are that's just another showing of the Arduino board. All right, so now into the coding type. So if you have real Arduinos, then you will need to do part 1 and 2 here. This is setting up your Arduino in the Arduino environment. So, yeah. So if you have Arduino downloaded on your computer, then you would open it. Why mine's taking so long? IDE. I would have to go up here. I've got new versions. I'm going to skip this version for now. Okay, so I would need to tell it that I'm working with an Arduino. Right now, I don't have an Arduino plugged in, so there's nothing there. I would need to tell it what port I'm plugging into. Oh my gosh. I don't want all these new updates. No, no, no. Should have done all of this prior to. So obviously, if you are on Chromebooks and you have IT involved, you can see even here, like I already have it installed, but there's an update. So, it can involve some IT work to make sure that you have it set up, but you would have to pick the Arduino Uno board. That's the one that typically comes in a kit, and then tell it what port it's in. If you're doing it online, there is, so in Tinkercad, you don't have to do any setup. And then online Arduino, I don't think you have to do any setup as well. Okay, but what you do need to do is the coding piece of it. So everything I'm doing here is in the Arduino environment, but it is identical to what is in Tinkercad. Okay, so you have a setup spot. This is global variables. And then this is setup code. So global variables are typically used for your pins. Okay, so when you have your pins, like that is not going to change throughout your coding environment. What will change is the value of your pin, like your pin might be high, your pin might be low, or maybe you want to tell it to be on for 5 seconds, and then you want to tell it to be on for 10 seconds, and then you want to tell it to be on for 15 seconds, and maybe you're using a variable to control that. Those are going to be ones that change. But your pins, like where your components are plugged into, really should have no bearing on that. So those are great things to put up here as global variables. Then we have setup. So setup is saying, okay, I have my LED plugged into pin 9, but is it an input or is it an output? Okay, so that's your pin mode. And then here's where your loop is. So this is the actual code that the Arduino is going to do. So global variables, typically where you have things plugged in. Pin mode is telling it, is it an input, is it an output? And then here's going to be where you're going to tell it what to do. So you can have comments. Comments are with double slash lines. Variables are not required, but are very important to coding. So I'll show you guys why that is in a little bit. Variables have to have a single name, like there can't be spaces. You have to declare what type of variable it is. So in this case, we're primarily going to be using integers. Integers are whole numbers. And then you have to have the assigned value. Different types of variables, different names of variables, assigning variables. So when you use a single equal sign, encoding is where you are assigning a value. So I'm assigning the value of 6. So basically everywhere I see the word LED pin spelled exactly like that, I can just in my brain erase LED 6 and replace it with the number 6, right? But me as a human, the number 6, I'm like, what is it? Like maybe is it 6? Was it 9? I can't remember. Whereas LED pin is much easier for the human to interpret and to understand. So that's one of the main reasons we want to use variables. But when you're using a single equal sign, you are assigning a value. Different benefits of variables, easier to read, easier to change. You can reuse code. The setup, again, this is where you're telling it, okay, I'm in pin mode. I'm telling pin 9 to be an output. I'm telling pin 10 to be an output. Like I'm telling it what I'm expecting it to be. So in this case, the LEDs are going to be outputs because I'm going to be telling the LED what to do. Here I used pin 9 and pin 10, but I really don't want to write pin 9 and pin 10. I want to use variables. So instead of pin 9 and pin 10, I'm going to declare my variables above in my global variable section to say I'm plugging in my red LED to pin 9, I'm plugging in my green LED to pin 10, and now I'm never going to use the number 9 and I'm never going to use the number 10 again. I'm only going to refer to them as red LED and green LED. Okay, this is the actual loop piece. So the loop is where you can put all your code. In this case, the code is only 4 lines long. You can have code that's 1,000 lines long, right? But this is where you're going to put your code that is going to control the LED. So in this case, or to control anything, right? But in this case, we're going to control an LED. And like I said, we want the LEDs to blink doing Morse code. Okay, so the first thing we're going to do is we're just going to have it blink on and blink off for half a second each. Okay, and so in order to tell the pin what to do, I have to write a value to it. I have to tell it. I don't want to read the value because that doesn't help me, right? I want to tell the LED what to do. So I'm going to use digital write. I'm going to talk to my red LED. So notice I'm not using the number 9. Okay, I'm actually putting in the word red LED and I'm saying hi. What that does is it's going to send 5 volts to pin 9. Then this next line is a wait. So it's going to delay for half a second. That does not mean that my LED is on for half a second. It means that the computer's code is going to wait half a second before it reads the next line of code. So that means whatever I told it to do before is going to continue to do. So because I told it that my pin needed to be on, for the next half second, that pin is going to stay on. Okay, then I'm going to digital write low. That's going to turn my LED off. And then I'm going to delay for half a second. Again, it doesn't mean the delay does not make my LED turn off. What it does is it waits half a second before going to the next line of code. So it will continue doing whatever it was doing before. White space encoding does not matter for the computer science side of things, but it does matter for the human that, we want to try to avoid white space that's all off and staggered. Like it should be nice and neat and should be common coding practice. Okay, and then if you're using the real Arduino, then you're going to have to compile and download. In Tinkercad, you just start the simulation. Um, the two types of errors that your students can run into are syntax errors. This is the most common. This is, I went to the store to buy candy, right? But candy is misspelled. So um, obviously that is just a typo. You fix that, you're good. Um, in coding, the most common syntax error is forgetting a semicolon at the end of every line. So at the end of every line, there has to be a semicolon. The kids forget that all the time. Semantic error is logic. So I store went to candy buy, right? There's no typos, but it doesn't work. Um, so the syntax semantic error can be either the code works, but it doesn't work the way you want it to. So maybe uh, I went to the store to buy hot dogs, right? When really what you wanted to do is I went to the store to buy candy. Like this is gonna work, right? But you're gonna come home with the wrong thing. It can also just be the actual semantics don't work, like you put things in the wrong order. Um, so that would be it. So in coding, a common one is like forgetting to divide by 0 when you're doing a percentage amount. Okay, so what we're gonna do together is just blink a light for half a second on, half a second off, and your homework is going to be to use Morse code to do your initials. Okay, so moving to Tinkercad, I'm going to start a new project just so that I can preserve this. So I'm going to click on the little Tinkercad up in the left-hand side. That'll take me back to my home page. For my home page, I'm going to create a new circuit. Okay, so I go to create circuits. I'm going to bring an Arduino, rotate it. I'm going to bring a breadboard, rotate it. And then I'm just going to build a simple circuit with just one LED and one resistor. Okay. And again, instead of connecting 5 volts to my power rail, right, I'm going to connect pin 6. Doesn't matter what pin, you can use any of the pins 1 through 13. Okay. I am going to just change the color to know that that is my pin. Oh, actually, so typically when you're talking to a pin, instead of giving it power, you use orange, yellow, or white. So that indicates that it is a data line, or maybe I'm expecting data to flow as opposed to red, which is like I'm sending it power. So even though it is power, it is not direct power. It is power controlled by the pin. So the yellow wire, like the color of the wire does not actually change anything. Again, that's more of a following the student's logic, being able to walk through it and having those visual cues. Okay, and then I do still need to ground my circuit, so I can connect it directly to ground this way, or I can connect it to my ground rail and then connect to ground over here. Doesn't matter how you set it up, but you do need to have a completed circuit. So I'm going to have pin 6 going to my LED, going to my long leg, going to my anode, which is then grounded. And if I hit my start simulation, do you think my LED is going to light up? Give me a thumbs up if you think it's going to light up and a thumbs down if you think it's not going to light up. We got 1 thumbs down, 2 thumbs down, 3 thumbs downs. Yes, that is correct, right? Because there's no power going to it, right? I have to tell pin 6 what to do. I mean, right now it's just plugged in and the default is that all the pins are off. Okay, so even though my circuit is correct, my LED is not going to work. If I move this and plug it in directly to 5 volts, now it'll work. Okay, but we don't want to do that. We want to control it through pin 6. So you're going to go over here to the code section right next to your start simulation button. The default is block based. in high school, we believe students should be able to code in a text-based environment. So we do encourage text-based, and that is how all of everything is set up, is text-based. It's going to say, are you sure you want to close it? Yes, continue. Okay. What you'll see here is some default code that pops in here. So this is pin mode LED built in, and it is an output. And then void loop, digital write, LED built in high, LED built in low. Okay, so what that is it's this little pin right here, the L. So if I press start simulation, my LED does not light up, but this little orange light blinks. Okay, so that tells you, and this is true on the physical boards as well. If you plug them in directly, it comes loaded with like the default code that pin 13 or that pin is going to blink. That just tells you the board's working and it's functioning. So if you ever have a board and the kids are like, the board's not working, like just load this default code into it and you can check and make sure that it is in fact blinking. And that is just the built-in LED. So I'm going to stop my simulation and make this a little bit larger. Okay. Yes, you can do this after the meeting. So if you're kind of lost, it might just be good to just listen and then, do it after. And the same thing can be for your students. If you see some students that are struggling to like listen and follow along, they can just listen. I do think that, there is value in trying to follow along as things are happening and then doing it again yourself afterwards. But if they're getting really caught up in being behind, then we don't want to do that. And they can just listen. So if we go back to our slides, we know we have our three parts, right? We have our global variables, our setup, and our void loop. And because the default code is to blink a light, we already kind of have a starting point. They are not using a variable because this is already set up as a variable name. But in our case, it's not built in, so we do have to declare it. So the first thing we want to do is say, hey, pin 6, I'm talking to you. Let's get set up. Okay, so pin 6 is an integer. It's a whole number, so it's going to be an integer. So the text for that is int. I have a red LED plugged in. Maybe you have a different LED plugged in, but I'm going to name it red LED. So it doesn't matter if you name it red LED or if you name it red LED or if you name it R LED. You can name it Bob or SpongeBob. Okay, your kids are going to try to do this. This is fine. It will work. It will be A, very hard for you to grade, and B is just really bad coding practice because nobody who comes behind them is going to be able to know what SpongeBob is. So if you've got SpongeBob and who's the little orange guy, whatever. If you've got all the different characters,
Patrick.
right? Patrick, thank you. If you've got Patrick and SpongeBob, like which one's the red LED and which one's the green LED, you're gonna get all confused. And it's fine if maybe you can remember two, but if you've got 5 or 6, like you just get lost. So you need to name the LEDs or the variables something meaningful. But if you don't like to type a lot, you can just call it RL, whatever you want it to be. Okay. But whatever you name it is what you have to use for the rest of the code. Okay. So I'm saying it's an integer. I'm naming it red LED. And I have assigned it to pin number 6, semicolon. Okay. Always have to end with a semicolon. Okay. If you plugged yours into pin 9, or if your students plugged them into pin 9, no problem. Oops. You just have to make sure that whatever's on your physical board or your virtual board matches your code. Okay, so I'm going to put it back to 6. I'm going to move this back to 6. Oops. Okay. All right, so now I've declared this as a global variable, so I'm assigning pin 6 to be called red LED. they've already got pin mode set up for me here, so I'm actually just going to use this as my starting point, and instead of built-in LED, I'm going to call it my red LED, and it is still an output. Okay, output must be in all caps. Pin mode must have a capital M. This is part of the syntax. If you do not do that, it will not work. Okay, so you got to have it exactly. The capitalization does matter. Very hard for kids to understand because they're so used to texting and typing and capitalization, who cares, whatever. Capitalization matters. All right, so pin mode, red LED, and it is an output. The reason it's an output is because we want to tell the LED to turn on or to turn off. We're not going to ask the LED for any information. So it is an output. So then if we just update this code that they have here, it is a digital write because we're in a digital pin. We are going to write red LED. High, we're going to wait for half a second. So the default is milliseconds. So it's 500. You can see here my comments say to wait for 1000 milliseconds, but I changed it to be 500 milliseconds. This is a great way to catch cheating. If they copy paste code from each other, they will tend to be like, oh, let me just be smart and change this to 250, but they won't update the comments. So, I always make the kids comment, and it's a great way to kind of catch cheating, especially if they, depending on how much they comment and the types of things that they say in the comments. I tend to like comments that more describe the behavior, the overall behavior, as opposed to a single line. So here, this is describing an individual line. So let me show you what this might look like. So this would be like, send 5 volts to red LED, right? Something like that. And then send 0 volts to red LED, right? But this is like individual line coding. What I try to encourage the students to do is to say, blink the red LED for 0.5 seconds on and off, right? So that's describing these 4 lines of code. It's describing the behavior as opposed to like what each individual line is doing. Like what each individual line is doing is great. Send 5 volts, wait 500 milliseconds, send 0 volts, wait 500 milliseconds, right? But describing the overall behavior is really like a good practice as opposed to each individual line. Okay, so I've got my pin set up. I now have my pin mode set up, and I now have my loop set up. So I'm going to start my simulation. I did everything right. It plugs in and it should blink, and if it's not blinking, can someone find the error?
You're in 9.
Thank you. Perfect. Did that on purpose. Sometimes you will do things on purpose. Sometimes you will do things not on purpose. And it's okay. You find it either way. All right. So good catch. You saw that my physical board did not match my code, right? I had this as pin 6 and it was physically plugged into pin 9. So now I'm going to start my simulation, and now it is blinking half a second on. Ooh, why isn't it turning off? Someone catch the other error. This one was not on purpose. Does anyone see why it's only saying
They have LED built in still in there, not.
yes right here? Okay, so here I did not change this to red LED. So what it was doing was it was saying, hey, red LED, turn on, wait half a second. Then it was moving on and it was saying, okay, go to the built-in LED and turn it off. Well, it was never telling this one to turn off again, right? So now I've got that one fixed. So great. We had one on purpose error and one not on purpose error. So now you can see it's blinking for half a second on, half a second off. I can change this to 1000. Okay. Now it'll blink on for 1 second, off for 1 second. Okay. Here's why variables are important. I want you to now change your wire to pin 9. Okay, you don't have to necessarily do this, but just listen, just watch. With variables, I just go 9, and now it's fixed everywhere, right? Now everywhere that I use the word red LED, I have a 6, or I have a 9 instead of a 6. If I had not used variables, I would have had to change this from a 6. I would have had to change this from a 6, and I would have had to change this from a 6, right? So like the longer your code is, the more you have to, like if you make a change and you're not using variables, there's just so much more room for error. Okay, so that's why variables are super important to change it to the right pins, or to, you know, to use the variables rather than hard coding it. Okay, so your homework assignment for this particular activity is going to be to build the circuit and then to add a second LED wired in parallel so that they're independently controlled. Technically, everything's kind of in parallel if they each have their own pin. So I'm going to bring this to ground, or I can set up my ground rail, right? So maybe since now I have two LEDs, maybe it's worthwhile to set up a ground rail. Okay, and then connect this to a different pin. So truly does not matter what pin you use. You can change the colors if you want. Let's see, I'll make mine Christmas colored. Okay, and in your code, you're gonna do Morse code for your students. So a dot is 1 second, a dash is 3 seconds. There should be 1 second between dots and dashes, 3 seconds between letters, and 7-second delay between words. So if the kids want to write their first name and their last name, right? So it's got all the instructions. I know that I just went through that super fast, but let me just, I'll show you for the letter V for Vanessa. So V is dot, 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 dash. Okay, so for a dot, 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 dash, what I would do, I'm going to do this really fast. Don't panic. So I'm going to use comments and I'm going to say V is dot, 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 dash. Okay, so then I'm going to copy paste this and I'm going to say, okay, I'm going to turn my red LED on, and I saw that a dash was 1 second and dashes are 3 seconds, and 1 second between dots and dashes. So I'm going to say I want my LED on for one second. That's my dot. I'm going to do it off for 1 second. Then I'm going to do, so if you want, I can do a comment dot. See, I'm able to reuse my code, right? Dot, 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 dash is going to be 3 seconds. So I'm doing the high is going to be 3 seconds. And I should have, before I copy pasted this, updated my comments. But so you can see quickly how if they copy paste their friend's code, you can get real off on your comments. Which you don't have to have these individual comments, right? If you're commenting the overall behavior, this is a dot. Okay, so a dot is on for 1 second. So dot, 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 dash. And then the other piece is between letters, there should be a 3-second delay where neither LED is on. So this last delay where my red LED is off should be 3000. That's gonna be my dash. And then if I do the letter B, B is dash dot dot dot. Great. So these are my initials. So I'm just going to reuse my hash code. Okay, you're going to have some kids who do it this quickly. Okay. And you're like, holy, okay, they're gonna get through this super fast. You're gonna have other kids who are like typing out one word at a time or one character at a time. So delay 3000. It's not a delay 3000 because this is not going to be between letters. It's going to be, I'm only doing a second delay between blinks. So, and I'm also going to set up my green LED, which I then have to set up here. Okay, and I have to set up here. Put it in pin 4, semicolon. Okay, so I declared it. I set it up as an output. I've got V is ... dash. My B is dash ... So then I'm going to copy my dot code, ... And then at the end, I'm going to put a 3-second delay because I'm going to be switching letters again. I've got to switch all of this to be green LED. Great. So if I start my simulation, I have ... dash, 3 seconds. Then both LEDs are going to be off for 3 seconds because I'm switching letters. Now my green LED is a long 3-second. Dot, dot, dot. Okay, and then it's a long 3-second delay where I would be switching letters. Now it's going to go back to V. So it's a loop. It's going to repeat. So it's going to do V, B, V, B, V, B. Okay. I know y'all are probably like, I was cool until this example. Okay, but the idea is the same, right? You're getting that light to blink on and off. All we did was add a second light, declared a new variable, and followed the instructions on the student handout in terms of the length of time for a dot versus the length of time for a dash. Okay. So set up 2 LEDs and do at least your first initial and your last initial. Feel free to do more than that. You will have some kids who, like I said, just finish it as quickly as I just did mine because they get it. They might even do it more efficiently by using functions to have a function that's a dot and a function that's a dash. I mean, kids can go ham on this. It's like really, the sky's the limit. So in terms of like competition with your kids, you can challenge them who can do it in the least number of lines of code. Okay. If they're just typing it like this, everyone's going to be about the same. But kids who are advanced in coding are going to know how to set up functions and are going to know how to do that. You can, again, if they finish this in 5 minutes, send them on the internet to find something else to program. And instead of just copy pasting, code from, an Arduino metronome thing, have them write their own, figure something out themselves. Or if they find a code on the internet, tell them they have to make 5 changes to it before they can submit it in for bonus points or something like that. Okay. The sky's the limit with Arduino. They can literally build and program anything. So homework number 1 is to do your initials in a Morse code format using high-low digital rights. Questions, comments, concerns? Great. All right. The last piece, 1 second. My husband's calling me probably about my car tire. 1 second. Cool. All right. To submit the Morse code assignment, you can hit the send to button here and it will actually send me, oh, that's only going to be the actual design. It's not the code. You can either take a screen cap recording of it. You can just copy paste your code. You could basically just take a screenshot of this. You can do a short video of you describing it. However, you are most comfortable submitting the Morse code assignment. But I will open it up on Google Classroom. So you can just whatever, whether it's a video, a screen cap, like copy paste into a Word document. There will be an assignment on Google Classroom that I will open for you to submit it to. Okay, the last piece is part 2 of computer science. So part 2 of computer science is also in the teacher notes. So I know I have the teacher notes open somewhere. That's electrical. Close a couple of my tabs. Here we go. Computer science. So this is just part 1, Morse code. And that's just examples. So here's sample code for Morse code for John. Okay, let me find part 2, which is the extension project. That should not say lesson plan. It should say teacher notes. We'll fix that. So right here is the PowerPoint slide deck. Again, it tells you, here's part 1 again, skip it if you already did it. And so we're going to go to part 2. Okay, computer science part 2. You need all the stuff you did for part 1, but this time we're going to add a push button. Okay, so instead of just controlling an LED with inputs and outputs, high, low, we're going to actually set up a push button. In this case, we're just going to give them the diagram on how to set it up. So we're not asking them to understand why the push button is the way that it is, but basically you've got power, you've got ground, and then this is your data wire. So this is the wire that is going to be controlling the push button. So I'm going to leave this up here for a second. If y'all could all in Tinkercad, go ahead and set up your circuit to match exactly this setup. Oops. So go ahead and take just a second, and I'm also going to set mine up in Tinkercad. So if you want to go back to the home page of Tinkercad and create a new circuit, okay, and then you'll build the circuit that is shown right here. Okay, so I'll give everyone just a second to do that. That'll be a little bit of practice. It is really important to put your push button across the trench because you don't want these to be in the same row. Okay, so it is important that your push buttons stay right in the trench or across the trench. So just set it up exactly how it's got it shown there. You know, it doesn't have to be the exact same spot on your breadboard, but that you make sure that, you know, one leg of your push button is in the same row as your resistor. The other leg that's on the same side of the trench as the resistor is power, and then the data is on the far side. Okay. I have mine set up. It's a little bit messier looking, but it is essentially the same as what we have here. Okay, so I've got my resistor in terminal 1A. I've got my power in terminal 2B or 2A, right? So A's are on the same side, and then I've got my data wire in terminal 1B. All right. Does everyone have their circuit kind of built? I'll give you guys, I see a few people still looking, so I'm gonna give you guys another second to do that. All right. Hopefully everyone has your circuit built like this. So this is the circuit that the students will be working on. So I have mine plugged into pin 3. So that is what I will be using in the code part of my assignment. Okay, so you should, again, because this is computer science, we want to give them the wiring schematic and focus on the coding part of it. We don't want them to like struggle with um, the actual building. But what you have is the red and the black is going to be your physical circuit, and then the data wire is this one that's plugged in over here to the pin. So we have the same components for our program. The only difference is that now the push button is going to be an input instead of an output, because we, the human, are going to provide input. We're going to tell it to, we're going to physically push a button, and we want the Arduino to be able to get that as an input. We also, it's an integer because our pins are all whole numbers. So we label that as whatever you want to call it. I'm calling it push. And in this diagram, it looks like I actually had it in pin 2. So that's why you have pin 2 there. Whenever you start having inputs and outputs where you're trying to read information, sometimes it's really nice to use the serial monitor, which is a way that it's going to actually print information for you so that you can more easily debug and see what's happening. So if your code's not working, you can use the serial monitor to see what is the value of my push button, right? Does the computer or does the microcontroller think it's on, or does it think it's off? And does that match what's physically happening? So this isn't a new line of code that is really helpful that you guys should be in the habit of using. It is not required for the code to run and function, but it is something that's super helpful for debugging. This is the 9600 is a baud rate. No idea what baud actually means. It has to do with the frequency and the signals that it's sending. Basically, I just tell the kids like type that in exactly how that is, and we do it in the setup where basically I'm telling the serial monitor, I want to talk to you. Okay. And then down at the bottom, it'll have the baud rate, and this is where you can find the serial monitor in Tinkercad. I'll show you guys where it is. So when we talk about using a push button, we introduce pseudocode. So let me put this in slideshow mode. So pseudocode is where we use the English words to kind of describe what we want it to do. So well, the one we just did was turn an LED on for 5 seconds, turn it off for 5 seconds. With a push button, we're going to say, if the push button is pressing, turn on the LED. Otherwise, or else, turn it off. The key thing in this is we're using the word if. So it's conditional, right? If something is happening, I want something to be done. Okay. And so this introduces the idea of an if statement in your computer science vocabulary. So if statements, it basically evaluates whether the condition has been met or not met, and then it's going to do an action. So if the condition is true, everything that's within the braces is going to be done. If it's not true, those commands are ignored. If loops only happen once, if statements are only run once, loops are run continuously, right? So you can create a loop around an if statement if you want it to check an if statement a whole bunch of times, but an if statement is by itself is just run once. So this is the syntax for it. If this is true, do this. Okay, so this is the logic for it. So if my push button is pressed, I want you to turn the LED on. Okay, otherwise turn the LED off. Okay, those are the three pieces. If this, do this. Okay, so if the button state is pushed, I need to fix the formatting on this. So first thing I'm going to do is read the value of the pin. Hey, pin 2. Oops, sorry, Lolly. I knocked and the dog woke up. Hey, pin 2 or 3, like whatever pin my pin is pushed into, what's your value? That's what this line is doing. Okay. Instead of using the actual pin number, I'm going to use my variable that I named it. Then I'm going to say, hey, I'm going to name a new variable and I'm going to store that value. Okay. Because when I say, hey, pin number 3, what is your value? I have to store that somewhere so that then I can refer to it in my code. So that's the button state. So I'm going to say, hey, pin 3, what's your what's your value? It's going to say, hey, I'm being pressed. Okay. Then I'm going to take button state and I'm going to say, okay, it's pressed. I'm going to store that value and I'm going to hold it in my bucket. Okay. And so you can actually do that all in one step. I can assign button state as a variable and I can assign it to always read the value and assign it all in one step. Okay, and then I want to print that value so that I can look at it. So maybe I'm physically pressing the button, but for some reason the code is not actually reading that value correctly. Okay, so here I'm going to assign a bucket where I'm going to store the value of the pin number, and then I'm going to print that value on a screen where me, the human, can see what the computer is storing in that value. Okay, so this is what it's going to look like. I'm going to declare a variable called button state, and I'm going to assign it the value that I read from my pin. Then I'm going to print the value. Okay, then I'm going to say, okay, now what do I want to do? If the condition is true, then I want to turn on the LED. So in order to check if the condition is true, I use my comparison operators, less than, greater than, equal to. Notice that this is a double equal sign. So when we assign a value, we use a single equal sign. When we're comparing, asking if it's equal to, we use a double equal sign. Is equal to, is not equal to, so this is just a comparison operator and the kids are going to interpret the code and get the results. So is 75 equal to 75? True. Is 100 equal to 175? False. Okay, so that this is just a little exercise they can go through in the classroom. Equal to, greater than, so on and so forth. Going through all of these. You can do these as a group exercise. Okay, but so basically I'm going to check to see if the button is pressing. So is my button state equal to high, meaning is it on? The double equal sign, I'm asking the question or I'm comparing. Is button state high? So I read the value and I stored the value. Now I'm saying, now, okay, I need to go look in button state. Are you high? And then if it's high, here's my parentheses. Here's what I'm going to do if it is high. I'm going to write to my LED and tell it to also go high, right? So if I'm pressing the button, turn my LED on. Okay. If this condition is false, so if I say, hey, button state, I want you to go read the pin, guess what? I'm not pushing the button, so that value is 0. It is off. Okay, then it's going to say, hey, if the push button is high, it's going to say, nope, 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 I'm not on. My value is low. Okay, then it's going to skip this line and go to the else statement and say, okay, let me write low. And so that's going to turn my LED off. Notice I don't have any delays in my code. Okay, so in our previous code, we had delays because we wanted the LED to be on and then we wanted it to stay on for a certain amount of time. So I used a delay function. Here, we don't want the LED to be on for a fixed amount of time. We want the LED to be on based on an input from the user. Okay, so it's not a fixed amount of time, but it's actually going to require the button to be pressed for the LED to be on. And when the button is no longer pressed, the LED will be off. So there are no delays because it's not being controlled by time. It's being controlled by the value of the button state. Okay. In the regular Arduino, there's an auto format. I'm not sure if it's available in Tinkercad. We will try it out. Okay, but so this is your final code of each of the steps with commenting. And now it is your turn. Okay, and here's a little tutorial for the actual physical computing. This is a 21-minute long video showing you how to add a push button to the Arduino. Like when I tell you there's probably no lie 400 videos on the internet showing you how to add a push button to your Arduino and how to program it. They're all different. They're like anywhere from 3 minutes to an hour long. You can find whatever resources that you want out there to help describe this. There's just literally infinite resources on doing tasks like this. Okay, so going back to Tinkercad, if I can find my Tinkercad. Okay, so I physically wired it. I'm going to go to my code. I'm going to go back to text because I opened a new project, so it's going to default back to blocks. Okay. I don't have my LED on here, so I do need to add my LED. So let me actually go back to here and add my LED circuit. So we have the push button, but the LED, they should be able to wire on their own. It's going to be your simple circuit. So again, I want it to be not just on forever. I want it to be on and controlled via my data wires. Okay, so my push button is in 3 and my LED is in 7. Okay, so yours might be in different places, but that's where mine is. So my first thing to do is to do my global variables. Your global variables are generally going to be your pins. Where is your stuff plugged into? So integer, because my pins are always whole numbers. I'm going to say red LED is equal to 7. And integer push is equal to 3. Okay, my LED is in pin 7. My push button is in pin 3. I need to set up my pin mode. So my pin mode here for my output, I can just copy this or delete this and put red LED. Okay, and then my LED is an output, but my push button, is my push button an input or an output? It's an input, right? Because I'm going to be, me, the human, going to be providing it an input. So my push button is an input. Woof, type something weird. Okay, all caps must be all caps, will not work if it is not all caps. Okay, so these are the two elements that I have on my board. I have a push button and I have an LED. And now for my loop. Oh, wait, I forgot to set up my serial monitor. So serial dot begin 9600. Again, they don't need to necessarily know exactly what how, the serial print monitor piece of it. We're really just, all we're doing is turning it on. So serial dot begin 9600, you can just have them straight copy paste that code. That is basically just going to initialize my serial monitor, which is down here. So the serial monitor is where I can print information so that I can see what does the code think is happening. Okay, so in my loop, I'm going to first check the status of my push button. Okay, so sorry, here we go. Okay, so the first thing I need to do is check the status of my push button. So I want to do a digital read of my push button. Okay, so that is going to read the value of my push button, but I need to store that somewhere, right? So I need an integer because I know the value, it's a digital pin. So the value is either going to be 0 or 1. It's going to be high or low. There's no in betweens. So I know I can store that as an integer. And I'm going to name it button state, just like I did in the slides. Okay. So I can have an integer button state and then this, but somehow I need to assign them to one another. So instead of having two separate lines that are disconnected, I'm actually going to say the integer button state is going to read the value of my push button. Okay, so I'm declaring the variable and assigning it in the same step. I could do int button state and then just do button state equals this. So I can declare it once and then assign it a value. So it can be separate steps, but that seems silly. I can just do it in one state. So why are these integers declared up here and this integer declared within my loop? Does anyone have any thoughts on that? Why are these integers up here and this one is down inside of my loop?
Because that one's only used in your loop.
Right, because that one's going to change, right? It's going to be used in my loop and it's going to change values. Sometimes it's going to be high, sometimes it's going to be low. It's going to depend on whether I'm pressing the button or not. So I can't declare it as a global variable because a global variable is not going to change, right? Those are your pins. That's not going to change. It's going to always be pin 3 or pin 7, or if I change it, I'm going to change it once, right? But that button state is going to be the current state of my button. So it's always going to be evaluated. It's always going to be checking it and it's always going to change based on whether I'm pushing it or not. So I can't declare it up above. It has to actually be in my loop because I need to check it down here. Okay. So I could, and I'm sorry if it's confusing if I keep saying like, well, you could do this, but I could declare it up here, right? But not assign it a value. And then I assign it the value down here. That is possible, but you would never assign the value up here. So I just find it's easier if you just declare it and assign it all in one step. All right, so I've created my button state and I've assigned it a value. And now I want to see what the computer thinks it read. Because did it read it correctly? Not sure. So I'm going to actually print the value of button state. Okay, the print ln, that's an L. That basically means it's going to print the value and then go to the next line. Print the value, hit enter essentially, and go to the next line so that it doesn't just print it all super horizontally. Okay, now I need my if statement. So if my button state is high, okay, that means that I'm pressing the button on my computer, open brackets, close brackets, else, open brackets, close brackets. Okay, so you notice when I set up my if statement, I went ahead and built out the whole structure. If my condition, and then here's what's going to happen inside, else, here's my condition, or here's what's going to happen inside. The else does not have a condition. because you're basically saying like, if the button is pressed, do this. Otherwise, do that. I don't need to say otherwise, if the button is not pressed, do this. It's just if this condition, and then everything else is not in that condition. Okay. So if my button is high, then I want to turn on the red LED. So that's a digital write red LED, and I'm going to give it a value of high. Else, red LED should be low. Again, capitalization matters, semicolons matter, white space does not matter. So I could totally have this, a bunch of white space here. The white space doesn't matter other than for the human. Same with commenting. Commenting does not matter to the computer, but it does matter to the humans. So if I add comments, I'm going to say, read the button state value and print it. I'm going to say, when button is pressed, turn on red LED. That's the overall behavior that I'm trying to do with that code. Okay, so that's my code. Let's see if it works. So I'm going to start the simulation. And I noticed right away that my LED turned on and my button is not pressed. And I see here in my serial monitor, which I opened right here, this is my serial monitor, I notice that it's a value of 0. Okay, so it thinks that the button is not being pressed. It's a value of 0, but for some reason, the LED is turned on. So I have to figure out why it's not working. So let me look here. Because see, it says if the button state is high, digital write high. So let me press my button. Nothing is happening. Oh, see, look at my serial monitor. The serial monitor here is 0. It's going to change to 1. So I'm going to press the button to 1. Okay, so this is how you debug. Okay, and this is literally the hardest part of this class, being a teacher, is debugging the program. Okay, so I'm pressing my button. So I'm clicking, and you can see in the serial monitor, this is why the serial monitor is so important. The value of my button is changing. Okay, but for some reason, my LED is just perpetually on. So that means it's not really doing this part of it. So when the button is high, it's not doing this. And when the button is low, it's not doing this. So does anyone have any thoughts? This is a really subtle error, and I did not mean to make this error. Does anyone have any thoughts?
Do you need a
I see it.
double equal sign? Oh.
Yes, very, very good observation. I did not mean to make this error, right? But here I said, if button state equal high, I told it that the button state was high. And what I should have been doing is checking if the button state was high. And to check, I have to do a double equal sign. So that was a really subtle error. Did not mean to make the error. But from a teaching standpoint, this is the most frustrating part. Okay, this is the hardest part, because until you kind of become comfortable and become an semi-expert, right? You're gonna have a hard time potentially identifying where the error is. So rely on the other kids, right, in the class. Be like, hey, I don't know why this is not working. Let's compare code with someone who is working. Okay, and let's go line by line and compare why is it not working. And it'll just take a little bit of practice and a little bit of time. to go through and figure it out. There's no amount of training or coaching that I can give to you guys, and there's no like list of errors that I can give you, because no matter what list I give you, the kid's gonna have something that's not on the list. It will take a little bit of practice. So this was a great example of a semantic error. The code worked. I was able to press play and it did something, right? And I could tell by my serial monitor that when I pressed the button, it was correctly reading the value of the button. So I knew the problem was somewhere in my if statement. So I was able to use that debugging window to, go through it that way and to figure that out. And so, yes, the problem was that I was assigning a value of high. So of course it was saying, yeah, the value's high. Here we go. LED on, even though when I was reading the value, it wasn't actually high. Okay, so now I'm going to press start simulation. Now my LED is off. So hopefully when I press the button, yay, it's on. And when I release the button, it's off. So you can see down here, my serial monitor is 0. My LED is off. When I press the button with my mouse, it turns to 1. My LED turns on. Okay, so it is doing the behavior that I expected it to do. I know we're a little bit over on time. The only other thing I want to show you guys is the other type of error, which is a syntax error. The two biggest problems the kids have: semicolons and parentheses. Okay, if they delete the parentheses, the curly brackets from their loop, or potentially from their if statements, and they start it, they're going to get errors down here. Typically, these are very easy to read. Error: I expected a curly bracket at the end of input, and it tells you it's on line 29. Okay, it says after line 29, I was expecting an error. And then I say, I have an open and a close. I have an open and a closed. I have an open, but I don't have a closed curly bracket. Okay, so if I add a semi bracket there and I start simulation, it works. Okay, and then semicolon is going to be the same thing. So if I don't have a semicolon and I start it, the code will not run. So these are syntax errors. Line 25, expected a semicolon before the curly bracket. So I go to line 25. I say, before the curly bracket, I was expecting a semicolon. Great. Okay, oops. Okay, and then you start simulation. Okay, so the student assignment for this is to do what we just did, okay, which you walk them through. And then the expansion to that is to have them, the expansion to that is to have them do a press button that when they push it and let go, it turns on, and you push it and let go and it turns off. So like your TV remote, you press it once, it turns on. The TV, you press it again and it turns off, rather than having to hold it the whole time. And so that should be also in the student handout. This is the student handout for the extension project. So you have basic and then the extension project. So, oh wait, no, sorry. This is the extension project is actually, I have this in the wrong spot. This is the extension project that should have been in electrical. Sorry about that. I don't know how all these got all mixed up. Okay. Yes, that was the extension project for electrical. The extension project for computer science is not posted there. So I will fix that, but it should be correct in the teacher notes. The Arduino coding challenge. So while holding the button down, turn the LED on. When letting go, the LED turns off. So that's the challenge that we just did in class. And then there's 2 additional challenges that the students can do. Okay. So one is to have LEDs in parallel and have them light up 1 second at a time until you let go of the button. And then the third, or the other challenge is to have 3 buttons. Each one corresponds to a light. And then the bonus challenge is the TV remote option. So that is, so your homework assignment, just as a final recap, is to submit me 4 assignments. 1, your LED circuit with just the basic single LED circuit for electrical. Your parallel and your series circuit, no coding, just the circuits. Both of those we did in class today. So if you did them and followed along, you can just screenshot those and send them in, or you can choose to redo them on your own just for your sake of practice and turn them in. Or if you've got a little bit lost, go back and watch the videos and do those and submit them by Tuesday is when, or by Monday, I'm sorry, they're due on Monday. The second part of the homework is computer science. So you should blink your initials in Morse code, and then you should add a push button and have it do just what we did in class today. When you push the button, the LED turns on. When you let go of the button, it turns off. If you want to challenge yourself, you can go to challenge 2 and challenge 3. But the only thing I need turned in are the first challenges. All right, I know that was a lot of direct instruction. This unit is kind of a lot of direct instruction. So when you are, thinking about implementing this in your classroom, know that this is a heavier, like, here step by step by step, because there's like just a certain amount of structure and procedure that needs to be followed before the kids can go off and explore. You will have vast levels of experience when it comes to this in your classroom, so rely on the students who are experts on coding to help the other students. You might find some additional helpful videos that you think are particularly good for your students. Call me, text me. I'm happy to be on call for a Zoom to help debug. I've done it literally tons of times. People are like, I cannot figure out why this is not working. We hop on a Zoom, we look at it together, we figure it out. Like while you're in class with your students, like happy to do that. The only times I can't are 9:30 to 10 or 9 to 10:30 Tuesdays and Thursdays. I'm teaching in the fall. Otherwise, I can generally help. Even if it's after class, like if you're like, we all looked at this, nobody could figure it out, like call me, send it to me, happy to help. It is a skill and it just takes time to like hone that skill. All right. Questions, comments, concerns?
I have a question.
Yes.
We have to download that Eduardo, you said?
Arduino, no, you do not need to download Arduino. You can do everything in Tinkercad, which is all just online cloud-based. If you have the physical Arduinos, in your classroom, which I don't have one right here, but like if you end up getting the physical boards, then you would need to get the real Arduino software because you can't use Tinkercad and download that directly to your Arduino. You have to use the actual Arduino. They do have a cloud environment for Arduino that you can download, but it does still involve like drivers and you still have to get IT involved. So, but it is not a requirement at all. So this is one of those projects when you look at the supply lists and the costs, I think it's got it at like $35 per kit, 1 kit every 2 kids. So it's, it's like $400 or $500. You can do it 100% totally for free through Tinkercad, just like we did here in the training. So yes, the code can be copied from Tinkercad into the Arduino software. It's the exact same coding environment. It just doesn't have the capability to like plug it in and actually transfer it to the Arduino board itself. But yes, it is syntax and semantics and everything. It is identical. Other questions? Cool. If y'all liked me before today and today you're like, wow, really don't like Vanessa anymore. This class sucks. Have faith. It's not that bad. It's a love it or hate it activity. And it does get better with time and practice. And you can do it. All right. If you're free to go, the sign out word will be, we'll just say hump day. Since we had camel as our intro word, the sign out word is hump day. It's 2 words. But anyway, I will stay on the call as long as you need, and I'm happy to redo any activities. And I will try to post these videos. It takes me a while to post them because they don't process till like 3 or 4 o'clock in the afternoon. And then I have to download them, put them on YouTube, and then post the links. And sometimes I don't remember to do it after the kids go to bed. So you saw them all post this morning at like 5 in the morning from yesterday. So I'm sorry if you are looking for those. They just don't process until like 3 or 4 o'clock in the afternoon from Zoom for me to be able to share them. So anyway, you're free to go. Thank you so much. I'll stay on as long as y'all need.